Let's discuss on-site oil analysis for municipal fleets. Why do on-site oil analysis? Well, first of all, let's talk about typical fleets. A municipal or a city fleet nowadays generally has many sets of the same model, brand, or grade of product. For example, you could have things like passenger buses, construction equipment, bucket trucks, police cars, sanitation vehicles, plows, all sorts of types of vehicles that are used on the normal running of a municipal environment or a city. And each one of those can have between 1 to 7 separate fluid compartments that all need to be checked, monitored, and updated on a regular basis. And some of these can be on multiple vehicles. So for oil lubricated systems, the vast majority of fluids nowadays are still consumed by passenger car and heavy duty vehicles that are in the type of municipal environments. And oil is consumed by engines, hydraulics, compressors, final drives, transmissions, pumps. All these types of assets and equipment, rotating machinery and reciprocating, is common in fleets. The big concern with fleets is that essentially there are two maintenance approaches that are employed. There is a reactive and a preventative approach. The reactive, of course, is fix when the system is broken, when the bus or the truck is broken and you have to bring it back to the shop and then do the repairs. The other approach which is used, of course, is preventive maintenance, where you're changing oils, you're changing components on a defined interval. Both of them are used, but the vast majority of best-in-class organizations have gone to some sort of preventive maintenance. And even if you are farming the work out to an external vendor to do this, they're going to charge you for that PM work to be performed. So how do fleet managers actually try to lower their costs? Well, it's a continuous effort. So nowadays, there's really two approaches. One is to consider investing in newer fleets. The argument is that you can improve reliability if you've got newer vehicles on the road. And if that's the case, your replacement cost over time versus the PM cost, you can make that calculation. Or you can also do more efficient preventive maintenance inspections and try and keep that vehicle on the road longer. This is particularly important for the high value assets that take several years to procure, maybe a certain bus fleet or a particular bucket truck or construction equipment, which takes longer than, say, typically fleet cars like police vehicles, things like that. So one of the things that we should think about is what is exactly a PM inspection activity. So fleet maintainers, as we said earlier, are trying to continually lower their costs. And one of the challenges, of course, is how do you lower that cost and maintain availability? A PM that is typically performed on any vehicle in the shop or the garage where the vehicles are housed can involve a number of different activities. So the obvious ones would be changing oil, fluids, filters, transmission, coolant, check or replace transmission systems. You also need to check while the vehicle is in. You need to do some quick checks like transmission mounts, drive shafts, CV joints, braking systems, electrical checks, steering, suspension. There's a variety of different tasks that are required that are continually being demanded. These times, not to mention the cost of the fluids replacement or the parts replacement, but it can be anywhere from 2 to 15 hours of a trained mechanic's time, not to mention the time that the vehicle is out of service while it's going through that process. So because of that, on-site oil analysis is a really great tool for fleet maintainers to try and get a handle on these PM costs. Why? Because if they're running oil samples as the vehicle comes into the bay, and do it in the first 8 to 15 minutes when the equipment is available, they can get information straight away about the condition of the equipment. That allows them to extend the drain interval if they need to. It means don't change the oil if it doesn't need to be changed. That means they can reduce or compress the amount of inspection time needed to check those fluids. They also save on oil and filtration costs. They don't have to purchase those. They can say to their environmental manager that they're reducing their carbon footprint by reducing disposal costs and improving the overall health of the city. And they also can look at the wear side of the oil analysis and look at advanced warning for mechanical faults. So they can decide, based on the information that's provided, if the vehicle needs to be repaired before it goes out in the field so that you can avoid a costly breakdown or tow charges. They can avoid disruption and last minute concerns. And they can plan the repair on their own time if they have advance notice. That's particularly important in this day and age because labor is at a real shortage. You want to maximize the efficiency of your trained mechanics to do the most critical work. And you want to coordinate to have all your parts just in time, ready for when the vehicle is there so that you're doing the work on your time and not on somebody else's schedule. And when the vehicle is ready. Cities who have adapted oil analysis and have started to do this on-site analysis concept report back to us that there's a 30% reduction in unnecessary PMs across the board. That's real money in terms of time savings as well as the component changes. So what is the typical type of equipment that we mentioned earlier, the components that are typically found in fleet applications and municipal fleets? Well, obviously you've got engines, transmissions, final drives, pumps, hydraulic systems that are quite common on a lot of your major equipment like buses, construction equipment, and of course you can also have it on passenger vehicles. So what are we concerned about? Why do we do an oil sample? What information can we get out of it? Well, the concerns why we do it is to get more information on some key concerns, such as extending the drain interval. Now, what we mean by that is the oil could be the right oil that you spec'd on it, but it may not be meeting the duty cycle of the actual application. So it may be that it's overheating or it's breaking down before its scheduled PM. So it's important to know that. You want to check if there's water contamination. It's quite common. If you get water into the engine, it's going to have problems. Coolant contamination as a result of coolant leaks, things like that. Lubricant mix-up. We may have put the wrong oil in by accident, or we thought we were putting in brand X when we should have been putting in brand Y. We put a transmission oil into an engine oil, stuff like that. We can have a fuel dilution problem if we've got leaky injectors, we got timing issues, retarding issues. We didn't do a compression test or a cylinder test on our engine. That's where we're going to see some fuel dilution showing up, or we'll need to do that work. Dirt, obviously, sand and dirt because we don't change our filters properly. And of course, wear. Wear in engines, especially for municipal, tends to be more on a trend basis. We don't see abnormal large wear unless there's a severe problem. For transmissions and systems like that, we're worried about solid contamination, dirt getting into clogged filters. If you've got a bucket truck or construction equipment and you don't have the wiper seals properly set correctly, you can draw a lot of dirt from the rod right into the oil line, and that's going to cause you problems later on, especially with stickiness or stiction on the controls. Water content, wrong oil again, the wrong oil or the oil is overheating, worn gears, bushings, things like that, that's all going to be a role in those areas. And particularly for transmissions and final drives, the wearing components on that is a real concern. For pumps and hydraulic systems, again, solid contamination is a big concern as well. We want to be looking for water, we want to be looking for wear. In this situation, again, we're looking for filtration issues. In the case of water and any other contaminants that are present in there, we want to make sure that those systems are working properly. There's nothing worse, for instance, to have a sanitation truck lose the hydraulic system on its run because now everything is stuck until it gets back to the shop, and that can happen quite a lot if these things are not maintained. So the key tests that we look for are things like total base number. That's an indication for the level of oil change in the end, for extending drain interval. We look at oxidation and nitration, of course, to determine the engine performance. If we've got excessive nitration, we know that there can be problems with the turbo. We know that the engine's not running properly. Oxidation, if the oil is already being harshly or overheating. Viscosity is the most important physical property. We always want to be able to look at 40 and 100 because we're dealing with multi-grade oils on almost all municipal fleets. So having that 40 and 100 is a really, really powerful solution for this application. Contaminant elements are the typical elements that you might see: silicon, calcium, barium, all varieties of materials that can be coming up. Usually they're in there and they're an indicator that there's something contamination. Your traditional wear elements are fairly standard stuff nowadays. You're always going to get iron. You get a lot of bearing and bushing wear. You have a lot of tri-metal bearings that are occurring, roller element bearings on a lot of the new engine designs. And you're starting to see more advanced sintered metal, things like that showing up as well. Additive elements are a function of the oil. So if the oil is starting to degrade or drop out, or there's a mix-up, you want to check for that. Water content goes without saying. Less water in a piece of equipment, in engine oil or hydraulic oil or turbine or transmission oil, is far better than you want to keep it clean, cool, and dry. Glycol, same situation. We don't want to have glycol as a result of a coolant leak. When glycol does get into an engine oil, it's actually extremely aggressive, and it creates a lot more wear than just water alone. It's well known that in the research facilities, we dose engines that we want to fail with coolant in order to be able to accelerate the failure. Soot content, obviously that's an indication of your fuel-air stoichiometric ratios as well as your air filter. You need to be able to keep the soot control under control. Ferrous debris for your transmission and for hydraulic systems to indicate when there's abnormal wear. And finally, fuel dilution, if you see lower viscosity and if you've got an injector issue, you want to get a direct measure on the fuel dilution. Up to 2% is considered to be normal. From 2 to 4% is a concern. Above 5%, you've got a potential concern there where you need to take the machine offline. In all of these cases, the solutions that we recommend here are the Microlab series. Why? Because it's a perfect all-in-one solution which is designed for the busy mechanic who doesn't have time to do a lot of testing in the field. So you can actually bring the vehicle into the bay, pull your sample, go right over to the Microlab, let the sample run, and then your report comes out with all your expert recommendations, and you're ready to move on and make a decision immediately on what to do. So the Microlab series is ideal for this type of application. For those rotating machinery components that you'll find on construction equipment and other large vehicles, add the FerroCheck for large debris. You have your fuel dilution as a backup for engine applications, and then of course you can have the companion cool check system if you want to look at the coolant quality that's on the coolant side of the engine system.